Welcome to the pre-calculus notes for Essential Skill E2, trig functions of all unit circle angles. We're going to build on what we did last unit in quadrants 1 and 2 and include all angles. So, we have the full circle at our disposal. Like last unit, we're going to identify the intersection point on the unit circle. The sine is still the y-coordinate, and the cosine is still the x-coordinate. The tangent is something that we didn't do last unit. It's just going to be y over x. We can form triangles if we need to. Some angles we won't even need a triangle. Don't forget that the unit circle is assumed to be on an xy grid. That means we can have negative coordinates in some of the quadrants. So we will account for sine. Let's start with an example. If we're looking for sine, cosine, and tangent of 120 degrees, first we locate that on the unit circle, and now we identify the coordinates of that point. Well, recall that the center is at the origin, and what we're going to do is connect these, drop a perpendicular to the x-axis, and that's going to leave us with a 30, 60, 90 triangle. This is a 60-degree central angle because it's formed between 120 and 180. 180 minus 120 is 60. Now, this is a 30, 60, 90 triangle, and so we can draw our version. Remember that the short side is half the hypotenuse, and the longer leg is related to square root of 3. When we scale this down to the unit circle, remember the unit circle has a radius of 1, we get 1/2. We get root 3 over 2. Since we're going 1/2 a unit to the left, that means that our actual x-coordinate is negative 1/2. And our actual y-coordinate is still positive because y is going up. I think you can see that in the future, y might go down if we're headed to quadrant 3 or quadrant 4. So, the sine is the y-coordinate, the cosine is the x-coordinate, and the tangent is y over x. The over 2's cancel. It's like we're canceling 1/2 from the top and the bottom. And we're just left with root 3 over negative 1, which is negative root 3. If we want to look at 225 degrees, we locate that on the unit circle. And we're going to drop, I'm using air quotes when I say that, drop a perpendicular to the x-axis. We're going to form a 45, 45, 90 triangle. And we can draw a classic triangle if we need to for reference, 1, 1, root 2, but we scale it down so that the radius is 1, so that the hypotenuse is 1. To do that, we divide everything by square root of 2. And so these become our lengths. And so when we rationalize, we'll get root 2 over 2. So our x-coordinate is negative because we went left, and our y-coordinate is negative because we went down. Now, if we want to find the reciprocal functions, first we'll find the sine of 225. That's going to be the y-coordinate. So the cosecant is going to be the reciprocal. To find the secant, we first find the cosine. That's the x-coordinate. It's the same as the sine, so its reciprocal is going to be exactly the same. Cotangent. Well, if tangent is y over x, then cotangent is going to be x over y. So, negative root 2 over 2, that's the x-coordinate, over negative root 2 over 2, that's the y-coordinate. Same thing over same thing, the cotangent is just 1, positive 1. Let's look at radian angles. The only thing that changes when we use radian angles is the way we find the point on the unit circle. Once we find the point, we find its coordinates, same as always. Let's look at this first example. Sine of pi over 6. We locate pi over 6. We can drop a perpendicular if we need to still, and realize that this is a 30, 60, 90 triangle. So we've got an x-coordinate of root 3 over 2, a y-coordinate of 1/2. So the sine is just the y-coordinate. Remember that if you need to, you can draw out the classic 30, 60, 90 triangle and scale it down so that the radius is 1. 5 pi over 4. Well, where's 5 pi over 4? Well, let's count the 45-degree angles. Here's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. There's 5 pi over 4. We'll drop a perpendicular. That's our 45, 45, 90 triangle. And so we can get the coordinates as negative 2 over 2, negative root 2 over 2. Cosine looks for the x value. We're there. Tangent of 5 pi over 6. Well, where's 5 pi over 6? 5 pi over 6 is going to be over here. The tangent is y over x. So our y-coordinate is going to be positive 1/2. Our x-coordinate is going to be negative root 3 over 2. So 1/2 over negative root 3 over 2. Once again, we can cancel the 1/2, and we'll get negative 1 over root 3, which we will rationalize. Cosecant of 5 pi over 6. Well, we just looked at 5 pi over 6. It's right here in red. The cosecant is the reciprocal of sine. So sine of 5 pi over 6 was 1/2. That was our y-coordinate. So cosecant is going to be 2. Take a moment and try the next two, and then I'll give you the answers. Here are my solutions. Notice that we already marked pi over 6 here in blue. So we're going to find cosine of pi over 6, which is just the x-coordinate. So secant is going to be the reciprocal of that, which we will rationalize. Cotangent of 5 pi over 4, we already marked that in green, right down here. Cotangent is going to be x over y. Same thing over same thing, the cotangent is positive 1. Let's look at quadrantal angles. This may be a new word to you. The quadrantal angle is an angle whose terminal side is on the boundary between quadrants. Well, what does that mean? The boundary between quadrants are the x and y axes. So, for example, 90 degrees. That's right on the y-axis. Here's 180. Here's 270. Here's 0 or 360. And these are special because we don't need to draw a triangle at all. Take a moment. Make sure you're good with radians. Fill in the radian quadrantal angles. Here are the answers. Now, let's look at trig functions of them. Sine of 270 degrees. Well, remember that the coordinates are measured as if this were the origin. If we go down 1 unit from the origin, that's just 0, -1. The sine is the y-coordinate, and so our answer is just -1. Take a moment and try out the rest of these. The practice will really help you get good at these fast. Here are my solutions. Cosine of 0. Without the degree sign, we're talking about radians. The x-coordinate is 1. Tangent of pi over 2. Well, that's y over x. Here's pi over 2 at 0, 1. So the tangent is 1 over 0. Tangent of pi over 2 is undefined. Cosecant of 3 pi over 2. Well, here's 3 pi over 2, coordinates of 0, -1. Cosecant is 1 over the sine, so the sine of 3 pi over 2 is the y-coordinate of -1. So this is the reciprocal of -1, which is just -1. Secant of pi, here's pi at -1, 0. The cosine of pi is the x-coordinate. So the secant of pi is just 1 over -1. It's -1 again. And then the cotangent of 90 degrees, we're looking at 0, 1. Cotangent is x over y, which is going to be 0 over 1. 0 over 1 is 0. The last thing we're going to look at in this video are negative angles. Recall that we find negative angles by going clockwise around the unit circle instead of counterclockwise. So, to find the sine of -30 degrees, here is -30 degrees. It's one big step clockwise. So, the sine is the y-coordinate. Here's our 30, 60, 90 triangle. And so, that's going to be -1/2. 300 degrees. 270 would be 3/4 of the way around. 300 is an additional 30 degrees. So here's -270. So this will be -300. There is the angle. Now, the x-coordinate, we can make that 30, 60, 90 triangle, but by now, hopefully you're getting used to these numbers, and we can just see that the x-coordinate will be 1/2. Tangent of -3 pi over 4. Let's use radians on the right. 3 pi over 4, okay. Pi over 4 is 45 degrees, so let's count 3 medium-sized wedges. 1, 2, there's -pi over 4, -2 pi over 4, -3 pi over 4. Here's -3 pi over 4. And the tangent of that is going to be y over x. So we need both coordinates. That's going to be a 45, 45, 90 triangle. And so we're going to have coordinates of -√2 over 2 and -√2 over 2. X and y are the same. And so the tangent is positive 1. I'll do one more, the cosecant of negative 7 pi over 6. Pi over 6, that's these small wedges. So here's uh, pi over 6. Here's another pi over 6. Here's 3 pi's over 6. 4, 5, 6, 7. Here's negative 7 pi over 6. The cosecant is 1 over the sine. So we care about the sine. The sine is the y value. The y value is going to be positive, and it's going to be 1/2. You can go through the whole 30, 60, 90 triangle if you need to. But hopefully you should be growing out of your need for that soon. Take a moment and try the last two. Negative 90 degrees. Clockwise, 90 degrees. That's at 0, negative 1. Secant is 1 over the cosine, so the cosine of negative 90 is just the x-coordinate, which is 0. So this is going to be 1 over 0. Uh-oh, that's undefined. Cotangent of negative 4 pi over 3. Well, negative 4 pi over 3, those are big wedges, so 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Here's negative 4 pi over 3. And its coordinates, if we drop a perpendicular and do the 30, 60, 90 thing, that's going to be negative 1/2 root 3 over 2. The cotangent is going to be x over y, and so that's negative 1/2 over positive root 3 over 2. Once again, we can cancel the 1/2 from top and bottom, and we're left with negative 1 over root 3, which we will then rationalize. And there's our final answer. That's what we're going to do in the video. We're going to do the rest of the notes in class, but for now, you have enough information to do the first part of the homework. Thanks for watching.